From ContainerDays Hamburg, this video is proudly presented by DuxIT.
So first, a few words about myself. Clément, I come from the French-speaking part of Switzerland, if you had not guessed yet from my accent. My family name, last name, conveniently contains 10 characters, which means that I've got to choose the n8r.ch domain for my emails and my blog article. And I live on a farm together with my wife. She's a farmer who lives on the family farm. And I also develop some cloud-native applications for the farm, and I write about those type of stuff on my blog. So how old do your clusters get? So there was this website with the uptime of servers. Nowadays, it's not so common to have really old clusters. It's not seen in a positive way. But in our case, our Kubernetes clusters, they get quite old. And for us, we choose to do that, well, with rotation of certificates and certificate material, of course. But we choose to do that because we have a relatively low number of clusters at Post Finance, like 35 clusters, something like that, 1 cluster per environment and network zone. And we have lots of application teams which are sharing those clusters in namespaces. So we do kind of multi-tenancy, but through namespaces. And we do not want to migrate 300 applications to a new cluster whenever we want to provision a cluster in another way. We prefer to live migrate the cluster so that we have less work in total for the company. Something else about Post Finance. So we are Swiss bank, a couple million customers. So when we fail an update, we quickly end up on the first page of the news because people can't pay with their card in Switzerland. So we try not to make mistakes. And fun fact, we are running Chaos Monkey on all clusters, including production clusters, card payment services clusters. This helps us do upgrades during the day because all applications have to survive the Chaos Monkey. On some clusters, we kill as many pods as 4 one pod every 4 minutes. So a relatively aggressive Chaos Monkey, but that helps us ensure that we have proper SLA. So that's for Kubernetes at Post Finance. So what's our starting point? How do we manage our clusters now? Currently, we use a mix of Ansible and kubeadm to deploy our Kubernetes clusters. So we provision VMs with Terraform. Then we have to run a series of Puppet and Ansible scripts to deploy security tools. And that's the part that you don't want to look at. And we would like to get rid of that. That's why we switched to Talos. Then we have to register some nodes in an inventory. We run GitLab pipelines, which actually call Ansible playbooks. And in those Ansible playbooks, we do something similar to kubespray, but we had started with that before kubespray. So we do it. We do the same as kubespray. We run kubeadm commands to upgrade, initialize the cluster, join new nodes, decommission old nodes, and everything. So that's basically our workflow. Now, GitLab pipelines to call Ansible playbooks, which we have written ourselves to run the kubeadm commands to provision the cluster. But we'd like to go for something a little more modern. So we'd like to go for something like ClusterAPI. How many people in the room have already used ClusterAPI? Can you wave the hand? Okay, so I would say 20%. That's not everyone. So I will explain a little how it works. So ClusterAPI, the idea is that you have a management cluster on which you will add new CRDs. And those CRDs, you have, for example, a cluster CRD, similar to a pod CRD, but a cluster CRD is going to start a new cluster. You also have machines CRD, and the machines are going to be translated to nodes. A machine can be a virtual machine or a physical machine, a bare metal node, that doesn't matter. There is an abstraction which provides those machines for you. How many people have used Talos Linux? A bit more people, so 25%, I guess. So Talos Linux, for those who haven't used it yet, it's an immutable operating system. It's basically the Linux kernel and a few components written in Go. There's no SSH. You cannot run apt on it. There is no bash, no SSH at all. Instead, there is a component called machined, which is written in Go, as I just said, which handles some API requests and in which there are lots of controllers reconciling the state of your machine. So to make it short, instead of SSH, you use MTLS on port 50,000 to communicate with the Talos node with the Talos scuttle command. And instead of like applying configuration with Ansible, you send configuration documents in YAML format to the API server, and then there are a series of reconcilers inside the machine D controller, which will reconcile the state of the machine. For example, if you want to change the MTU of the network device, you create a network config YAML, you patch the nodes, and the reconciler will automatically apply the new MTU. So that's about Talos Linux. So we come from the old world. We want to go to ClusterAPI and Talos, but we don't want to lose anyone during the process. As I said, some services are quite critical. We cannot afford a downtime of 1 hour because people couldn't withdraw money or pay for 1 hour. This doesn't work. So we have to do a live migration. And so this happens in several steps. First, we'll have to match the configuration of the old cluster, legacy clusters, to what Talos expects, or ClusterAPI as well. There are some bits to change. Then we'll have to import the public key infrastructure, the certificates of Kubernetes. We'll continue by creating some ClusterAPI CRDs, the ones that I showed before. We'll see that in the demo afterwards. Once that's done, we can start to increase the replica count of our various ClusterAPI instances. And then we'll start to see new machines, new nodes join the existing Kubernetes cluster. The configuration matching part, it's described in the Talos documentation when you want to migrate from a kubeadm cluster, but basically you have to specify the service account issuer, and it needs to match exactly the API server endpoint. And then if you use HCD encryption, you need to make sure that the encryption keys are the same as the file that is in the template for Talos. Well, I made a pull request to Talos. Hopefully we'll be able to upload a custom encryption config to Talos, but for now it's not possible. So you just have to make sure you use the same key names. And if you had to change the encryption key, then you have to re-encrypt all your secrets, but that's not as terrible as it sounds. It can be done quite easily, actually. Once that's done, you need to import the existing public key infrastructure, so all the certificates of Kubernetes. Luckily for us, there's a nice, oops, that's not what I wanted to do. There's a nice command line tool nice command inside the Talos Scuttle command line tool, which permits to generate secrets from a Kubernetes PKI folder. So you have, for those of you who have worked with kubeadm, you have your etc Kubernetes PKI folder containing the CA cert, etc cert, and everything. You just run Talos Scuttle gen secrets from the Kubernetes PKI. You also specify a bootstrap token, and then it will generate a secrets.yaml, which is a document which looks like that. And that's all Talos needs, all the Talos Scuttle tool needs to generate new machine configurations, which it will send later on to the machine nodes. Once that's done, we have to create some ClusterAPI CRDs. So on the left-hand side, we have a cluster CRD, and on the right-hand side, we have a Talos control plane CRD. But we'll get back to that in the demo. It will make more sense. When it's live, it's always easier. This explains a little how it works with ClusterAPI. So in blue, you have the cluster. Then you have the Talos control plane in yellow. And this Talos control plane instance or resource will then be monitored by a Talos control plane provider, which is the ClusterAPI provider for Talos. It will monitor the control plane resource, and it will start Talos machines as needed, and the same goes for the machine deployment. But once again, we will do that in the demo. It will be much simpler to understand. And how do we want to migrate our 6-year-old cluster? We have the first step is that we have our kubeadm existing cluster in blue. We start to add new nodes with ClusterAPI gradually. We want to have a hybrid setup for some weeks to make sure that we don't see some tricky sysctl parameter mismatch in the Linux kernel, for example, or stuff like that. So we add new nodes gradually, and over the course of multiple weeks, we want to get rid of the old nodes and to migrate completely to ClusterAPI. What can go wrong? Because stuff always has to go wrong at some point. If you not specify the service account issuer, you get this error message I've listed here. If you do not specify the encryption key, you get an error message which makes quite a lot of sense, no magic prefix found. If you specify the wrong HCD encryption key, then good luck for figuring out the error message. You get a failed to decrypt data. Output array was not large enough for encryption. So when you read it first time, you have to spend some minutes to understand that actually it's just that you used the wrong HCD encryption key. So let's get to the demo now. hopefully the demo gods will be with me. Otherwise, I have a recorded version of it, but it's much more fun if it's live. I think, yeah, it's big enough. I think everyone should be able to read, otherwise you can just go to the front row. So I'm using Tmux. I have a series of windows that I have prepared. Let's go through those. Perhaps the first window here, I have NeoVM opened for my lab-v cluster, in which I have my various ClusterAPI manifests. So we have the cluster manifest, for example, where I define the cluster name, the endpoint, the port, where I specify which control plane I want to use. Then I have the control plane manifest, in which we have our Talos control plane. For now, we can see that the number of replicas is set to 0. We don't want to spin up any machines. The data plane is similar. We have a machine template and then machine deployment. Analog to deployment, a deployment in Kubernetes starts pods, a machine deployment in ClusterAPI start machines. Then we have a document which references our infrastructure. In our case, it's vSphere, and a simple customization file with, which gathers all those manifests and also generates 2 secrets. The first secret is the Talos secret. So this one is the secrets bundle that I've showed before that we are going to generate just now. And the second secret is a secret which is expected by ClusterAPI, basically cluster ID-CA, and it needs to contain those 2 fields, TLS-CRT, TLS.key. On the other windows that we have, Talos Scuttle will run a few commands afterwards. Slides, just wrote my slides. etcd. Here we are on one of the old legacy control plane nodes. So we'll just run a watch on etcd Scuttle member list because we hope to get a member which joins this cluster in a few minutes. Then here, the 8th tab is the ClusterAPI management cluster, so CAPI cluster as we call those. We see a few namespaces. We prefix those with CAPI just to make it easier to find our stuff in there. And we do not have yet the lab-v namespace. It will come when we do the kubectl apply later on. So those namespaces here is where we are going to find our machines, clusters, and secrets and everything for all of our workload clusters. And finally, lab-v. This is the existing legacy cluster. We just have this is just a lab cluster, 6 nodes, 3 workers, 3 control plane nodes, and we'll see if we manage to get another node joining here. So one of the first steps we have to do, as I mentioned before, was the configuration matching, but I'm not going to do that in a demo. It would take too much time. It's already prepared and already done. The old cluster is already having the service account issuer set to the proper value, and the etcd encryption key is also set to what it needs to be for Talos compatibility. The second step is to import the PKI material. So for that, I've written a small script. Do I have it here? Import PKI, which I will execute on the old control plane node. So I will generate a kubeadm join token. I will generate the Talos secrets bundle with the command I showed before. I will read the encryption key from the existing encryption configuration file, and I will just use YQ to set it in the secrets bundle before printing out the secrets bundle to the std out. So let's do that. Yeah, I have to go in the proper folder, obviously. So here I'm in the folder for lab-v, and now I can run my command again. And normally, if everything went well, you can take picture of the encryption key. It's just the lab cluster, which will get reset afterwards. So that's not so much of a big deal. So now we have our secrets bundle file, which I'm happily printing out for everyone to take a picture. In there, we have the cluster ID secret. Those are stuff related to Talos. We have the Bootstrap token that we saw just before. The secret box encryption secret. This is the etcd encryption key of my existing cluster. etcd certs, Kubernetes certs, all of those certificate, all of this PKI material was just imported with the Talos Scuttle gen secrets command. Good, so we have our secrets bundle. If we check our customization file, we also need to have tls.crt, tls.key files. So I've just created also a file to import the TLS content. How did I name this file? Naming is always hard. Create TLS. So, well, that was not so original, but it should do the trick. Create TLS. So yeah, that's it. It created the tls.cert, tls.key. So we have our now we have imported our PKI material. So the next step that we are going to conduct is to apply our customization file. So let's do that with the kubectl apply-k and in the current folder. And let's move on to the cluster API management cluster. So we have on the 8th window, we have now a lab-v namespace. If we go in there, we should not find any pod. That's expected. We're working with cluster API, so let's list clusters resource instead. So we do have a new cluster, lab-v, which appears to be somehow provisioning for 22 seconds. If we describe it, we see some annotations, we see the spec, the endpoints of the cluster, and some status. And then let's check, do we already have machines? Normally, we should not have any machine because we said that we did not, we started with 0 replicas for now. Let's check secrets as well. We have our Talos secret bundle file. It's there, all good. We have a kubeconfig file. If you check the age of this file, it's only 22 seconds old, which means it's 30 seconds. It came 30 seconds later than my kubectl apply. I did not generate this file. Actually, that's the Talos control plane controller, cluster API controller, which generated this file from the CA certificate, which is just above. So it just generated a new kubeconfig so that it can connect to the cluster. Okay, so far so good. We could think that the next step would be to create a control plane node, but actually there's just one bit to do before that. If we check the Talos control plane node, Talos control plane resource here, lab-v, if we check the status here in the conditions, we see something like machines bootstrapped false. What this means is that the cluster, from the cluster API standpoint, has not yet been provisioned. So if I start a new replica now, if I start a new control plane machine, Talos will run the talos-kutl bootstrap command, which instructs Talos to create a new etcd cluster. We don't want to do that, otherwise we would have a conflict with the existing control plane nodes. So in order to work around that, we have to patch the sub-resource, the status sub-resource of the Talos control plane, and we have to set this field bootstrapped true. So let's go ahead and patch it. Patch the sub-resource. Okay, the sub-resource was patched. If we check here in the status, we should see, okay, status bootstrap equal true. So we do that to prevent Talos to send the talos-kutl bootstrap command, which would create a new etcd cluster. So what's the next step now? We have everything ready to create our first machine. So let's get going. Let's apply this customization again. And now, if we go back to the cluster API management cluster, we see that we have one replica, ready true, initialize true. If we check the description, we see that we are cloning a machine. So let's check the machine CRD. What do we have here? Okay, so we have a lab-v machine which is starting. Is it already in etcd? Not yet. It takes a few seconds for the machine to come up. What do we have in the machine YAML document? So we have a spec. It specifies which bootstrap config it should use. We have a series of status and conditions. And I would like to see if we already have an IP address assigned to the machine. Not yet, so we wait a little more. That's the perfect timing to drink a little bit of water. So let's check again. It takes some time to get the IP address in the field here. Do we already have the node in NCD? Not yet. Well, it takes 2 to 3 minutes for that to happen. While this comes up, I will try to generate the Talos config file. The Talos config file, well, let me generate it and then you will see how it looks like. Talos config, get Talos config. There's a small command, kubectl get secret. We get the Talos config. Here it should fail because we do not have yet the node IP address. So let's see. Well, that's normal. Let's wait for the IP address of the node to come up. But the Talos config is similar to the kubeconfig file, except it's not the same certificates because it's not talking to the API server of Kubernetes. Instead, it's talking to the API server of Talos itself. So in the Talos config, we have a CA, a cert, and a key. This cert and key is a certificate that you use to authenticate yourself to the port 50,000 Talos gRPC API endpoint. And this certificate actually has an OS admin role, which lets you run administration commands on the Talos nodes. So let's run the command again. Perhaps we got the IP address. Yeah, now we have it. I just also added the endpoints in here. Let's get back to the etcd screen. Well, now we have the machine has joined etcd, so that's good news. And let's perhaps also display the dashboard. So with Talos CTL, Talos CTL, you can run a dashboard command, which shows you the current state of your node. So we see that that's what you would see if you would plug the node to a console, actually. And it's, again, written in Go. So we see that the node is in stage booting. Kubelet is healthy. I'm not sure if it's already registered in the existing cluster. Let's go back to the NINS window. So it's not there yet. We should see it come up soon. And see, we see some logs. So we see that there is a controller which is waiting for etcd to be up. Apparently, successfully promoted etcd member. So we just had a successful start of etcd. It managed to copy everything from the old legacy cluster. And then it created a few static pods, so the kube scheduler, kube controller manager, and kube-apiserver pods, which means that the API server is going to start soon on this new control plane node. And well, we can continue to monitor that because it's not going to. It's going to use on control plane nodes per default on Talos. It's using itself as the control plane endpoints. So long as the pods have not started, it cannot register itself in the cluster. If we check ClusterAPI again, we see that the machine is now transitioned to the phase provisioned. And as we'll see in a moment, there's another stage after that which will be ready. But we are not getting there right now. We just need to wait a little more. So hopefully the demo gods do not fail me. How many seconds? 2 minutes and 20 seconds that we started this node. I think it should soon join the cluster. Let's be hopeful. Yeah, there we go. So we have a node which has successfully joined the cluster. Let's go check on the NINS window if we have it. OK, we have a node which is starting. It's not ready yet. It has to start a couple of pods, mainly Cilium, before being advertised as ready. But that's a good sign. So we have an API server running there. We have, well, those 3 static pods that we just saw beforehand. And we have Cilium starting up. And in a couple of seconds, we should see the number of tails decreasing as the pods get running. So yeah, Cilium is running. We can check the logs for Cilium. And if we go back to the nodes overview here, OK, cool. The node is ready. Join the cluster. So that's a good first step. There is still one taint. And it's related to the fact that I have, for now, disabled the vSphere CPI. vSphere CPI is a controller from vSphere which matches goes to vCenter, gets the UUID or the ID of the VM and sets that as an annotation or as a label on the node. And actually, ClusterAPI is waiting for that provider ID to be set on the machine to make sure that it's really running and healthy. So let's just restart the vSphere CPI daemon set. So I had added some tolerations. I had removed the tolerations, sorry. So let's add those back somewhere around here. Tolerations operator exists. So let's tolerate for any toleration, which we should not do, but it's fine for a demo. Now we have the vSphere CPI, which is starting up. If we check the nodes taint, it should soon decrease to just 1, and then in ClusterAPI we should soon see the count, the phase of the node transition to ready. So did it already happen in ClusterAPI? Not yet. This takes a few seconds. I'm too impatient. Yeah, now we have only one taint, which means that we should have on the node the provider ID. And here we have a running node, so a completely healthy node from the ClusterAPI standpoint. But we also have a failure. If you go back to etcd, we see that apparently on the all legacy nodes, we do not have any etcd members anymore. We can't actually read any etcd command. If we go back here, if I open a new Kubernetes session, we should see a lot of red stuff happening, or perhaps in an instant. What just happened actually is that ClusterAPI kicked the old etcd members out of the etcd cluster because it doesn't know about those nodes. From the ClusterAPI standpoint, it only knows the new node. And so what it did, it kicked all the old nodes. So this is something that you need to be aware of when you migrate. I think it was also mentioned in the retrospective migration this morning talk. It was the same. So make sure that your migration script is very polished before you run those type of commands. But that would be it for the demo. We have joined our cluster and we have a running node. So that's not the entire migration. The next steps will be to start new nodes, new control plane nodes, first of all, to have a healthy 3 nodes etcd cluster, and then worker nodes on the course of multiple weeks, as I described before. So with that being said, I want just to touch a word on the bootstrapping issue. So with ClusterAPI, something that you have is that you need to have a management cluster. And how do you get your management cluster first? Do you bootstrap it with ClusterAPI? Well, that's the chicken and egg problem that we call it. So the way we solve this problem is that we wrote a Go utility, ClusterAPI Bootstrapper, which actually starts a local kind cluster, checks S3 for encrypted manifest backup, and then restores those to this kind cluster, and then we let ClusterAPI run to manage the management cluster. And we can run this ephemeral cluster in a pipeline or on our laptop if we need to. So that's how we solve the bootstrapping issue, but we are not 100% happy with it. And there's something else, actually, independent of our will. We are not going to implement ClusterAPI right now, although everything would be ready for it. Because for us, we really like Talos. We want to go with Talos. But zero-downtime, the company behind Talos, they changed a little the priorities. They are no longer going to add new features to the ClusterAPI providers. They are just going to do basic maintenance on it. They shifted the focus to their offering, enterprise offering Omni. And so we also had some issues or concerns with ClusterAPI. All the bootstrapping issue, the management cluster, we are not 100% fond of what we implemented. And also, we do not have thousands of clusters. We have like 30 clusters, some of which are lab clusters. So we do not necessarily need such a solution, such a complex solution as ClusterAPI. So which other options do we have? We could go with Omni, the solution of zero-downtime. We tried it, but it acts as an API server proxy, and we do not need that, so we were not going to go with that further. We could use Ansible to wrap Talos scuttle operations, but we don't want to do that at all. Or we could use perhaps, we could write a purpose-built tool for Talos, because actually the commands that you have to run, and that's what you are going to do, there are not that many commands that you need to run for Talos. You need to gather some configuration manifests. You need to assemble those. It makes a big configured bundle. And then you need to do a Talos scuttle apply on your machine and perhaps run Talos scuttle bootstrap if it's a new cluster. But apart from that, most of the heavy lifting is already built in Talos itself. So yeah, we are building a really as simple as it can get open source tool, which will just do those minimal commands. So we will have in the end, at least for now, the same setup as we had before, a GitLab pipeline where we run this small tool. And in the future, we might go again to ClusterAPI. But for us, the blockers for ClusterAPI also was the fact that you always have to recreate new machines if you want to update the configuration. So I had not mentioned that before, but if you want to change the registry mirror of your node, for example, you have to create a new machine. And we do not want to drain nodes so frequently as like perhaps every week if you have a small config change every week. So for those reasons, we are going to for now, move to Talos with another solution that I will probably share on LinkedIn and that you might hear about soon in the future conferences. And I think that would be it for the talk. So let's get to the questions part.
Thank you. Let's go over to the questions. You have a lot. You already, I think, answered that partially. Have you considered using zero-labs Omni to provision Kubernetes clusters? Maybe just a few words. Why have you decided against it?
Yeah, so exactly. So I just touched a little bit on it. Well, the UI is great, but for what we checked it acts as an API server proxy. So all our API requests would go through Omni and then through our API servers. And we don't want that. We are highly regulated. Even if we could run Omni on-prem, we do not want to put so much responsibility on a third-party component that could break at any time. So.
Okay, let's see the next question. Talos can complicate diagnosing nodes. What has been your experience so far?
Well, if you're a cluster admin, you can start a debug container, a debug pod with the profile sysadmin, which means that you can then check all the files on the file system of the Talos node, and that's what we do when we have to do more advanced debugging. So with Talos Scuttle, you can run some basic commands like list, read files, and so on. But if you want to do more stuff, you can start an Alpine container in there. It mounts the host file system on /host, and then you can explore the Talos node like that, and you can run basically most of the commands that you would need to debug a node. That's how we do it.
How do you install Cilium? Has to be done during Bootstrap. As far as I know, I don't like Talos proposition to do it as inline manifest in the machine config too much.
It doesn't need to be installed at Bootstrap. You could do it, but we don't do it. We prefer to install it afterwards with ArgoCD. Actually, it's funny, when you start Talos, it's so fast to boot up that you have the API server running before the first control plane node even registers. So, which means an API server can be a Kubernetes cluster can be a cluster without any nodes, without any pod, without any deployment. So you can have a cluster which starts without Cilium at first, and then you can deploy it with another tool afterwards.
Thank you. Is it safe to have secrets with kubeconfigs from all clusters in the management cluster?
Well, this is also something that you have to be confident about. If you use ClusterAPI, your management cluster becomes really the entry point to all the clusters, because as you mentioned, you have all the secrets. We are not so fond of that, so that's also why we are going to go with another solution where we just pull the secrets that we need from Vault for temporary usage, and then it's again in Vault. It's not in a cluster. But then, yeah, well, that's up to you. I can't. It's hard to give a more detailed answer than that. My .files are open sourced. Clemonus .files repository. Go ahead, pick that up. Thanks. Why not create a new cluster, deploy the apps with ArgoCD, and switch over the storage and DNS? As I mentioned, the platform team is taking care of those 30 clusters or so, and on those clusters we have perhaps 500 different application teams working, and we prefer that we have a little more effort doing a live migration than to explain to 500 application teams that they have to switch the ingress endpoint, perhaps, or the storage endpoint, make a copy of their application to a new cluster. That's why we did it that way.
Thank you. How do you deal with troubleshooting for nodes which are running Talos Linux?
Well, I guess I touched on that a little bit before. With kubectl node shell, you can do already quite a lot. Yeah, I think that's about it from my perspective.
And how do you upgrade your nodes using ClusterAPI?
That's the thing. With ClusterAPI, you do not upgrade the nodes, and that's also why CDO Labs, they stopped doing they are not going to invest further effort in the ClusterAPI providers, or just minimal effort. You do not upgrade the Talos nodes, but you have to replace those. And that's quite a shame, because actually upgrading a Talos node is super simple. It works with an AB partition scheme, so you have your image. If you want to upgrade, it creates a new folder with the kernel in the SDS3 partition. It modifies grub, and then on the next boot, it's going to boot from the B partition. And if there is an issue, it goes back routes back to the A partition. So upgrading Talos is super safe and easy, so it's a bit sad that we cannot do it with ClusterAPI. That's also a driver for our decision to follow CDO Labs in abandoning ClusterAPI for now.
And maybe the last one, are you concerned about vendor lock-in?
of course. You should also be. We had a call with them already. The company behind it, CDO Labs, is a quite small company for now, 20 engineers or so. And if we go with Talos Linux, we'll probably make sure that we have some contract to make sure that they are not going to close the door on us and that we have to change operating system in 1 year. But their position is quite clear. They're going to add some enterprise feature like FIPS compliance and stuff like that. But they will keep the base code open source. So for how long this will stay, you can never tell. I mean, it's the same for all the nice and great open source out there. Perhaps they get CNCF sandboxed at some point. We hope to see that, but yeah, we are considering that. But at the same time, if you migrate to Talos Linux, you can also migrate out of Talos Linux. When you understand that your cluster is a bunch of manifests, some PKI material, and the HCD content, if you are able to build the tooling around the migration, then you can go away of Talos if really it went haywire. Yeah.
Thank you, Clément. If you have further questions, you can just come and ask him. Maybe you have some time.
See you around.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.